So basically this row U is in the middle. So you need to know the value on the side before and on the side after. So that's why we are using this Taylor series. At the end of the day, and on the left side you have row U, which is the value in the middle, plus this one, the additional value to the right, right? And that one is the value in the middle minus the distance. Okay? It's like you're having this, right? This one, the slope is 1. So you have this. At 1, it gives you 2. At 2, it gives you 4. At 3, it gives you 6. So the middle value is this. Right? Let's say this one is unknown, this one is unknown. Okay? So if you want to find this and that, what you need to do is to find the slope. What?
Substitute. Yeah.
If you get lost with this number, you get lost with that. Okay, so basically it's this, right? So you need to find the value. This one is the left, this one is the right. Got the idea? Okay, so that's the idea about this one. So you got that from this, yeah? If you want to derive it like this, right? Because we have time. Now you need to get this on the x direction, on the y direction, and on the z direction. When you do that, you will end up having 1, 2, 3. Any question about that? Right? So this one is taking account the mass crossing the boundary. The crossing the boundary, CS. Okay? So if you look at, we are talking about this one. If you remember, in your chapter 5, you have this, right? M in this one positive or negative? Negative. M equal to 0 when there is no accumulation. If there is accumulation, you have dm dt. So now we are talking about this. Get it? But we make it more complicated. Yeah. Just make it more complicated. You have this one. So this one is part of your CS. Control surface. Okay. How about your control volume? If you look at the control volume again, you know that the control volume, fixed scratch is volume, is nothing but dx times dy times z. That is your volume times the rho, right? You integrate it. You integrate this in the whole control volume. Why we do integrate? Because rho at any position can be different. Good. Very good. Okay, that's why you end up having d rho dt, dx, dy, dz. Okay, now you have a complete term, right? You have this one. You have that one. Any question? question should not any question, but do you understand?
No. Sir, could you repeat again?
Yes.
Tak ada right and left one.
Okay, let me repeat it again, yeah. When we are dealing with the control mesh, the mesh is constant, right? This is constant. Now the problem is, you are not dealing with the control mesh, you are dealing with control volume. Something is coming in, something coming out. Sometimes you have a storage, right? Storage within it. Let's say you have tank. You have inlet, you have storage, you have outlet. Right? This is your boundary. Okay, your boundary is like this, right? CS. Okay. Sometimes you have the volume within it increase, sometimes you have it increase, depending upon the inlet and outlet condition. If your outlet is faster or it drains more than your inlet, like you guys, right? Your parent give you 1,000, you spend 1,200. Go on, 200, borrow. Right. Or some of you are very good saver. Your parent give you 1,000, you spend only 100. The other 900, it's up to you lah. Right? Then you become a good saver, right? So now, when we are dealing with this fluid, we cannot use that anymore, right? dm dt is equal to 0, no? So we need to convert from this into that using our dt. You know transfer theorem. How many of you know that? Okay, if you do not know that, luckily I have put here fluid mechanics 1 refresher for you. Yeah? Right? How good I am. Give you all these things. Okay? So if you look at it, you will find out how we convert from a control mesh to control volume. Did you learn this in your fluid mechanics 1? No. Never heard before. Now you heard from me lah. Okay, since I have put refresher there, there is no excuse saying, oh sir, you did not provide it. Yeah, I provided that. Okay? So we are talking about this now. We still staying this. Yeah? We haven't touched this one. So we will move this. And we have to finish by today. Okay? Clear? Okay, so that's where it comes from. Now, this one is the changes in the control volume. This one is the changes or the mass flowing in or out of that control volume. Got it? Any one of you have a bottle of water there? Okay? If you drink it, you drain the water from the container, from the storage. So now the amount of water within the storage will reduce, and there is a water crossing the boundary. And in this case, the boundary is the boundary is the outlet of your bottle. That is the boundary. And the mass crossing those boundary is the one that we derived just now. Okay? Now, if you look at it, Okay, now we are talking about the first part. The first part is the changes within the control volume, within the container. The changes within the container is rho d volume. Because we are taking a very small volume, the volume becomes dx, dy, dz. Okay, this is actually just the side of your cube, right? You have dx, dy, dz, right? So your d dt become d rho dt, dx, dy, dz. Because rho dv is nothing but rho u times, sorry, not rho u, rho times this. Clear? That is the first part. Simple. Now the second part, something that is crossing the boundary. How do we do that? Coming back to your lovely cube, right? And you set in the middle, you have rho u. You have rho u in the middle because that is the core of your cube. Now the problem is I don't care about the core. I want to see what happened in the side. When there is inlet, at the side there is outlet. So we are using this concept. You know the value in the middle. You do not know the value on the side. So you need to get the slope. Right? That is basically what you get by using the Taylor series. Okay, when you are doing this Taylor series, the distance between both is dx over 2. Why dx over 2? Because your side is dx. You locate your point in the middle. Unless you want to make yourself complicated. I mean, like if you want to make yourself in trouble, you put it 3/4 or 1/4. It's up to you. That's your life. If you want to make it complicated, it's your problem, not my problem. Okay? For me, I want to make my life simple. I take it in the middle. By using Taylor series, I have the left face and right face. And left face is given by this, right face is given by that. So basically, this one is the slope. This one is the distance. Is that clear, ladies and gentlemen? Boleh? Can I? Can I get A then? Okay, so you do that, you get the left face and right face. Unfortunately, boys and girls, this one is only one direction, only in X. Remember you have X, Y, and Z. Right. So pretty. Now you need to do the same for the Y and Z direction, and you will end up getting this and that. Any questions so far?